we'll now do Newton's law of C. Number 5. And in this problem, it says that Dana picks up a 1.8 kilogram book with an upward acceleration of 1.5 meters per second squared. So the mass of the book is going to be 1.8 kilograms. The acceleration of the book is going to be upwards, so positive, 1.5 meters per second squared. Part A of the problem says, draw the free body diagram. Well, Dana has a force upwards on the book. I'm drawing the book as a dot. And then the weight of the book is actually in a downward direction. Notice that I drew the force of Dana greater because it is in the upward direction, and I know that there is an acceleration in the upward direction, so there must be a net force in that upward direction. Now part B of this problem says state the free body equation. Well, for this one, we're looking at the net force equals ma. So net force equals ma. Well, the force of Dana is upwards. Remember, up is positive. So the force of Dana, and then we have to subtract off the force of gravity because it is in the downward position, equals ma. And that is our free body equation. And finally, part C says, find the size of the force on the book. So what we're looking for is what is going to end up being the force of Dana. So for this problem, what we do is rewrite the free body equation, force of Dana minus force of gravity equals ma. Solving for force of Dana, I get force of Dana is equal to force of gravity plus ma. Now, we know mass and we know acceleration were given in the problem. So the next thing we need would be the force of gravity. Force of gravity is always mass times gravity, which in this case is going to be the 1.8 kilograms, as given in the problem, times 9.8 meters per second squared. So now you multiply these two together and you get 17.64 newtons. Plugging this into the equation now, the force of Dana is going to be equal to the force of gravity, which is 17.64 newtons, we'll round at the end, plus my mass, which is 1.8 kilograms, times my acceleration of 1.5 meters per second squared. Multiplying out and adding together, we get that the force of Dana is 20.3 newtons.